Virtualization is suddenly back in the spotlight. With VMware's changes shaking the market, everyone is looking for open, modern alternatives. And while OpenStack is one option, there is a lot of buzz around Kubernetes-based virtualization. Could Kubernetes, KubeVirt, be the next big shift in how enterprises run their workloads? Joining me today once again is Rob Hirschfeld, CEO and co-founder of RackN, a company deeply involved in infrastructure automation and Kubernetes operations. Rob, KubeCon is almost here. Just last week at Open Infra Summit, VMware migration was one of the hottest topics, with OpenStack emerging as a viable alternative. If you look at the Kubernetes world, what is the real state of Kubernetes virtualization today?
Wow. Kubernetes virtualization is a well-kept secret for people for years and years. There's a Kubernetes extension called KubeVirt that provides control for KVM inside of and through Kubernetes mechanisms. So it's always important to decompose this a little bit for people who aren't familiar with Kubernetes and only think of it as a container orchestration system. Fundamentally, virtualization is managed by a virtualization layer. For Linux, that's KVM, kernel virtual mode, which is an alternative to VMware. There's other ones too. Zen is a popular one. But for most Linux distros, most systems that are virtualization platforms, they're using KVM behind the scenes and then just managing the KVM instances when they start, stop, attach to networks, attach to storage. That's really what people are talking about when they talk about a virtualization platform. It's the thing that's driving the hypervisor, not the hypervisor. And I say that because it's important to understand when we talk about KubeVirt for Kubernetes, we're really talking about the control plane for the VMs much more than we're talking about the actual hypervisor and what actually contains the VMs. Kubernetes has a project called KubeVirt that is then wrapped by different distros. We do a lot of work with OpenShift, and so OpenShift virtualization is really a very highly aligned product on top of KubeVirt. You could even say it's minimally different than KubeVirt. And from that perspective, it's just a way to use the Kubernetes APIs to stop and start and live migrate and set up networking and storage for virtual machines. It's been in the Kubernetes community for quite a while, and it's a very mature way to run virtual machines using the Kubernetes control plane.
You mentioned KubeVirt, and there's clearly growing interest in it as a VMware alternative. But despite VMware's situation, adoption still seems limited. What is holding it back? What are the main blockers to broader adoption of KubeVirt?
Yeah, VMware has a lot going for it that people tend to forget. It has a very concrete storage approach, has a very concrete networking approach. It has a lot of administrative tools, which a lot of people affectionately call ClickOps, meaning you don't have to learn how to use a command line or automation to set up and manage virtual machines in VMware. And it also has a lot of adjacent tooling, backups, site recovery, standard formulas that people can use to just buy a whole working VMware system. And what we've seen is that ecosystem is only now emerging for KubeVirt. And that's one of the reasons why we see a lot of interest in OpenShift as opposed to just using upstream KubeVirt, is because Red Hat has been building up the ecosystem of capabilities and certifying the ecosystem of capabilities around what the actual virtualization offering is. And to be fair to VMware, in a sense, VMware is ahead of the pack in this whole ecosystem and what they build. Their networking and storage technologies and UX and control planes are really the market leaders in this case. And so replacing virtual machines often means finding replacements for every one of those technologies that goes into the stack. In the last year, KubeVirt's been making some really tremendous progress around the networking and network isolation, automatic failover, so being able to migrate VMs between machines without downtime. Storage options and attached storage has been really moving very well in that, and then building UX and portals to give people an administrative a vAdmin experience. All of those pieces are now in place, but and there is a worthwhile but here, a lot of people are still messaged and fearing that they're going to have to learn how to be a Kubernetes admin and start learning, dreaming about YAML and what they have to do with YAML to control the systems. That need has really decreased dramatically. And so what we've seen is this concern that you have to become a Kubernetes pro and an app developer or a platform team to run virtualization. That messaging, I think, is off point based on what we've been experiencing with our customers. You can really show up, run Kubernetes virtualization, OpenShift virtualization in a running cluster, and then manage VMs much more like you need to without having to become a GitOps pro or get scared by a whole bunch of command line interfaces. It's just not required.
Many organizations are asking if KubeVirt can actually replace VMware, but it's not turnkey. It's going to take time, and maturity comes with use. So it's catch-22. How should IT leaders approach this transition? What's realistic today and what isn't?
That's an excellent question. And one of the things that we have seen is that the market does need a turnkey approach to making KubeVirt work. And we've been very careful in our labs in building a turnkey solution that we find can come up in a matter of hours from an OpenShift virtualization delivery perspective using Red Hat's own APIs, controls, and command lines for the open compute pieces. Same exact technology would work for Kubernetes more generally. Our customers are generally asking for OpenShift, so we tend to focus there. But helping somebody say, this is how you do it, this is how you get it running, this is how it looks in production, right? I agree. That is something that the market has not done a good enough job in. This is a place where RackN has stepped forward to try and drive that forward. As a delivery where somebody can say, I need to move faster. I don't want to hire a consultant who's going to invent a new way to do it. There should be a standard way. We have done exactly that. That said, executives are looking for not just, can I deliver this? Can I deliver this quickly? Can I beat my next VMware renewal cycle? Because that takes a lot of time. That's the planning that people have to engage in to make it work. This is why we're so focused on speeding people up through pilots. And we actually have a concrete offer for pilot delivery to get people through that use case very quickly and then start being able to plan production. The goal here is not 100% replacement of VMware. Right? Ultimately, all of the customers that we talk to, all of our prospects want to minimize or zero out their VMware spend. That isn't a practical short-term goal. It really is a question of how do you pull the first workloads? How do you start the migration from VMware workloads off of that onto other platforms? And OpenShift virtualization, we think, is a great one. The simplest one, the most obvious one, is to run your Kubernetes workloads on Kubernetes. And that doesn't mean intermixing them. That means building a virtualization platform that you can then use as your virtualization layer for your app dev Kubernetes workloads. So not commingling and throwing VMs into the mix of all your other app dev work. What we recommend architecturally is treating OpenShift virtualization or Kubernetes KubeVirt as a virtualization layer with standard bounds on standard virtualization gear, very, very capable way to deliver that into production quickly, and then run that your Kubernetes clusters on VMs in that Kubernetes cluster. So it's still two different systems, two different life cycles. You're not trying to intermingle it. You don't need a single cluster control manager for both layers of your infrastructure. We find that approach, if you're an executive, if you're a leader looking at how do I do this, just replacing the virtualization layer and not disrupting your regular Kubernetes teams is a very effective way to do it. You can build the expertise you need to do virtualization. You can isolate the concerns so that you can figure out how to build a virtualization cluster that just does virtualization and then optimize and tune that. And the most logical workload to start with is to migrate your Kubernetes workloads onto that. That's actually a really nice workload. And then start identifying, the workloads that you have that don't require VMware as a networking or a storage technology. It doesn't require fancy backups. In some cases, we find that customers can't leave VMware because they have applications that are only certified in VMware. And so all of those items, will constrain your ability to fully exit a VMware footprint, and it'll take time to do it. But there's a lot of low-hanging fruit here. And I've said it several times now, Kubernetes is the lowest hanging fruit to run on Kubernetes virtualization.
When you compare KubeVirt to traditional virtualization, it feels more like a strategic shift than just another platform choice. What makes it different, and why is that distinction so important?
This is a really important point, and I think there's a strategic imperative to reduce the number of platforms that you're investing in and improve your knowledge base and what you can support. So a lot of companies that we talk to are very interested in consolidating the platforms that they're using into Kubernetes. We see that on app dev, it's already happened. On virtualization, there's an opportunity that we're talking about. We already see a lot of AI workloads being run, either inference or training, on Kubernetes also. And so at the executive levels, you can see a strategic alignment around Kubernetes as a common platform, which is useful for skills. It's useful for vendor relationships. It's useful for sort of streamlining the number of different vendors and tools that you have in your environment. I see that as a really powerful strategic imperative around OpenShift virtualization, Kubernetes virtualization. However, just because it's a common platform, I think people get confused and they assume that means that they've collapsed all of these use cases under the jurisdiction of one team. And so what I really encourage people to do is, when they think about Kubernetes as a strategic common platform, they don't get confused with the use cases all being smushed together into a single team or a single management infrastructure. We find it's much more productive for teams to treat virtualization as a use case and to have teams and infrastructure and buy bare metal for virtualization, just like they would buy infrastructure and teams for AI workloads and app dev workloads. They're very separate use cases with different needs. It's a benefit to have a common platform, as long as you understand that the use cases and the skill sets and maybe even the ownership of the Kubernetes platform in each of those cases might actually be a different team. And that's the thing that I see. I've seen a lot of messaging that was very confusing, that makes it sound as if the app dev platform team is going to own the virtualization platform in companies. And that platform team is focused on maintaining and running applications. It's not thinking about what hardware do I buy, how do I maintain it, what's my storage infrastructure, how do I isolate my networking, how do I run and support and patch bare metal. Those are all separate concerns. And so, I think that we have a fantastic opportunity to see alignment around this common platform. And we can make it go faster if we acknowledge that those use cases actually have different ownership or different flows inside of their systems. We've seen a lot of, unfortunately, we've seen a lot of companies take a very long time to do even simple Kubernetes virtualization pilots, because they end up asking the app dev teams to run those pilots, when the pilots, 80% of the work is infrastructure. And so, the simple advice, if you want to go faster, let those teams do what they do best.
Beyond your own customer base, what are you hearing from the larger Kubernetes ecosystem in general? Are these KubeVirt and virtualization related conversations becoming more mainstream, or it's still kind of niche?
There's a couple of types of conversations that we see in the industry. We definitely see more interest in KubeVirt in general, right? Not just from us, but across the different vendor ecosystems, with the caveat that a lot of companies that are looking to replace VMware need support, need somebody who's actually going to maintain and manage the underlying infrastructure. So what we don't see a lot of is open source Kubernetes, open source KubeVirt showing up in these enterprise accounts. It's the same reason the enterprise accounts are less enthusiastic about Proxmox, which we see having a lot of day in the sun. Even OpenShift, or not OpenStack, we see interest in that, but it's harder to adopt because you need for a virtualization platform, you typically need a very strong administrative layer. You need systems that have very high repeatability and conformance and vendor support behind them. Because you're replacing VMware, which has all of those pieces into it. It's, none of the customers we talk to are really then exploring an open source component. The other thing that we see as slowing down or also being a little bit confusing for people is this expression of bare metal Kubernetes as a generalized need or a generalized function. And that we do see, I see a lot of conversations and a lot of discussion about bare metal Kubernetes, and you don't need VMs, and run containers on bare metal and things like that. And then there's the communities trying to build the cloud interface tools, the cluster API components that are designed for VM management, down a layer into bare metal management. And bare metal is different fundamentally in many ways than virtual machines. But the simplest is that the consumption of bare metal servers in these use cases is actually very different. Because virtualization servers and AI servers are very expensive and wired and networked in very specific ways, it's not as simple to just create a pool of bare metal machines and deliver those as part of a cluster that you can generically treat. So what we find is that a lot of times when people think about bare metal Kubernetes, they get confused with, sort of cloud-like behaviors of checking machines into pools and doing automation. RackN supports all that. Digital Rebar has some really strong integrations that it can and do enable a CAPI interface. But for the use cases that we're seeing bare metal make sense, virtualization and AI, what we see is the need there is not to do pools of systems, is actually to build static clusters that have a known boundary, a known integration, have specific networking where each machine has to be set up to be part of a predetermined cluster boundary. And so I do think that it's confusing when I look at community and discussions where they think, oh, I'm going to have bare metal machines that make it so I don't need virtual machines. Those aren't good parallel associations. And I do think that drives some confusion where somebody's like, oh, I'm just going to buy a whole bunch of bare metal machines and treat them like a cloud pool and make everything go in and out. Just very simply, if you're buying bare metal machines, you're spending enough money that you don't want machines sitting waiting at a pool idle. If you buy machines, get them in use, put workloads under them. They should be delivering ROI for you. They shouldn't be just sitting waiting around in a spare pool. That said, we do have some interesting cases where people buy capacity and switch it like day to night, depending on their workloads, and they'll make a cluster bigger during their off hours by taking machines away from their daytime workload and switching it back. Those are some interesting use cases. But once again, you're about changing capacities dynamically here, not individual machines instead of VMs.
Now, for those organizations who are ready to explore KubeVirt, what practical steps should they take to start experimenting and building readiness, even if they're not moving straight into production?
Yeah, this is something that we've actually put together as a product because we have a lot of people asking exactly this question or creating a lot of frustration where they're pulling in consultants who are building bespoke systems without, they're just trying to figure out what to do. So what we've done is we've actually packaged up a full OpenShift delivery systems, soup to nuts, conditions, all right. We already have all the technology with Digital Rebar to fully inventory, condition, prep, RAID and BIOS configure and install the base infrastructure. We've added into that driving the OpenShift installer so that we actually can build the cluster following the normal install patterns that OpenShift supports and recommends, and then scale, update and scale the cluster beyond that. So that's all automated and standard. Recreating that is just wasting time, and you're actually moving yourself into bespoke controls. So what we really recommend is you want to spend your time learning how to build VMs, manage VMs, experiment with migrating your workloads onto and off of these platforms. The time that you're going to spend actually installing OpenShift or Kubernetes to make that work is really wasted time because you're not learning anything. Or in worst cases, and we've seen this happen over and over again, what you're learning is not translate into a production deployment. I have a customer who went through a pilot, thought everything was okay. They went through a second pilot, finished that pilot, and then the next consultant showed up to do another pilot and said, "Oh, you did this all wrong. We can't move it forward into production. We're going to restart." And they keep having a Kubernetes virtualization Groundhog Day. That is really problematic. We have solved this in a standardized way. It's the core of what RackN does, is show up not just with the automation platform, but with proven automation that comes with part of the product. And that allows you to get to a working endpoint very quickly. And then, what you need to be doing is training your virtualization admins on, how do I create a VM? How do I change its size? How do I migrate it? How do I, recreate the information that I have? That's the place we can do experimentation. And one of the fun things we've done, this is true of us across all platforms we support, is we help make tuning really fast. So there's an apply, rinse, repeat cycle that we enable for all customers. And the idea that you can literally say, hey, you know what? I need to tune my storage parameters or my networking topology, push a button and reset and rebuild the entire cluster. It usually takes about 20 or 30 minutes to go through all the reboot and rebuild cycles. That is incredibly powerful. It means you're not spending time relearning how to build everything. It gets you back into, that quick iteration cycle, gets your people with real hands-on using the product. That's where they're adding value into the whole cycle. So I've been really proud of watching the team do this. I think at this point, they have installed OpenShift more times than anybody else on the planet, because they're literally just going through tweak, tune, take advantage of this API. We've been putting bugs in against the OpenShift installer to, further tune and tweak our performance to just get every second out of that install time and make it as repeatable as possible. And so that's been really fun to watch the team, really build this, fantastic experience, not just around bare metal, but making these platforms really, really work. Because, as we mentioned earlier, there isn't the same level of expertise and standard patterns out there for OpenShift that there was for a VMware platform, where you just buy a set of gear and it would all come pre-wired.
How is RackN approaching Kubernetes virtualization, especially when it comes to simplifying hybrid and multi-cloud environments?
We help customers with all virtualization platforms available. So we've done a lot of work helping get infrastructure ready to run air-gapped environments. It's all self-managed gear, right? This isn't a service we offer. It's customers doing it for themselves in their own data centers, behind their own firewalls. And what we saw when we started working with OpenShift was that the ability to have a standard repeatable pattern was really important. And so that's what we've been focused on helping customers define. And the other thing that we've seen is that being able to have that, in a flexible way, and it's really nice with VMware. You had to buy exactly this, one server, network it this way. It was very constrained. The flexibility in an OpenShift environment to mix and match types of gear, to have multiple vendors in the mix, to have some more freedom in how you design the networking topology, that's a really powerful thing. And it shows up because we're doing OpenShift virtualization. Our OpenShift AI work is really identical. The only difference between those two workloads is installing virtualization capabilities or installing AI capabilities after you've built and managed the cluster. So we're very excited to see how much we can accelerate all of the infrastructure concerns under this, not just virtualization. And we're back to the power of that common platform.
Looking ahead, do you see Kubernetes-based virtualization will become the default model for enterprises, or it is going to stay a niche option used alongside other virtualization solutions?
It is a little early to tell. Looking at the appetite for this common platform and what our customers are driving towards, it is very clear to me that it has the opportunity to emerge. It's interesting to me because even if you look at some of these other platforms, this OpenStack is a good example. They're recommending using Kubernetes as the underlay for OpenStack. So, you start asking yourself, wait a second, if I have to install Kubernetes first, can I just keep it as Kubernetes? And Kubernetes is lightweight, incredibly powerful. It's well known in the industry, and so I do see this as the accelerating way to make these platforms work. That doesn't say it's we're all the way there yet. It does require more CLI work than there are times when you're going to say, all right, I have to drop to the CLI, or I have to do YAML, or I have to make something work to make it go. But on the flip side, and this is, I think, is really significant, the cloud native practices, being able to run your clusters through GitOps, having really strong infrastructure as code, immutable operating systems driving these components, right? All of those capabilities are showing up in the Kubernetes deployments that we're doing today. And I think that is a much more productive way ultimately to run your infrastructure. And so future-wise, it's the clearest path to a really dynamic cloud native style bare metal infrastructure of any of the alternatives that we have on the market at the moment.
Finally, can you talk about how are other vendors and distributions, Red Hat, SUSE, Canonical, and others responding to this growing shift towards Kubernetes virtualization?
So we are not seeing as much momentum on OpenShift virtualization from other vendors as we are seeing from Red Hat. Red Hat decommissioned their other virtualization platform, and they are really very much behind OpenShift virtualization, more so than we see from other broad vendors. We've seen some companies like Platform 9 that have been very focused on OpenShift virtualization for a long time, and hats off to them. But what we see that's a challenge is most of those distro vendors take the approach of it being a distro function, and they have a very vertically integrated stack. And so they have a tendency to approach this Kubernetes virtualization story as a fully integrated stack for them. Whereas what we've been trying to do, and why we see OpenShift is interesting here, is that we can actually create a real separation where bare metal and bare metal automation is a generic layer, and you could bring whatever you needed to it. If it's not OpenShift virtualization, you could bring in Nutanix, you can bring in Proxmox, you can bring in VMware. You could bring in Hyper-V, right? We actually see customers having needs to have flexibility and intermix those pieces. What we've then seen on top of that is, since they're already using OpenShift for app dev, it's very natural to think about bringing it into a virtualization mode, but not getting overly locked into that one platform or that one way of doing things. So, that really for us is the differentiation. And because you're going to need a degree of opinionated components on top of it, it's helpful for your virtual admins to have companies that are very focused on those value-added administrative tools on top. And so I would say if somebody's looking at different distros and different ways to do it, one of the questions becomes is, what type of administrative and ClickOps tools and visualization tools are being built for the virtualization layer by the distro companies. And I don't expect those to become community tools. I think those are going to be, like we've often had administration and management tooling, those are ones that are part of a distro's specific offering and unique to that distro.
Rob, thank you so much for joining me and sharing your perspective. It is clear that Kubernetes-based virtualization isn't just about replacing VMware. It's about rethinking how enterprises build flexible, open infrastructure for future. And for those watching, if you are exploring your own path towards cloud-native virtualization and automation, be sure to check out RackN and its solutions. And don't forget to subscribe to TFR, like this video, and share it with your team. Thanks for watching.